10 billion square meters of drywall are produced annually worldwide. This staggering amount is sufficient to cover the interiors of millions of homes from the United States to Europe. But this is just the beginning. Why has this specific material become the #1 choice for builders globally? It appears to be a standard commodity. However, the true answer lies in the complex industrial journey that turns raw minerals into the flat, durable sheets we see every day. At first glance, the product looks simple, but in reality, it serves as the sophisticated backbone of modern construction. One can notice how massive factories operate with strict precision to create these panels. The technology hides an intricate operation behind the smooth, white surface. The detailed look at the machinery begins here. 95% of homes in the United States use drywall for their walls and ceilings, making it the most common material in residential construction. Why is this specific composite so ubiquitous? At first glance, it seems like a simple building board, but in reality, its dominance is driven by a precise engineering balance. The secret lies inside the panel itself. Manufacturers grind gypsum powder and press it tightly between 2 layers of tough industrial paper. One can notice that this mix creates panels that are lightweight, fire-resistant, and provide better sound insulation than many traditional materials. A standard 4 by 8 foot sheet costs between $10 and $20 in the US. While drywall costs a bit more upfront than simple wood or plastic panels, the efficiency is undeniable. But this is just the beginning. Quick installation and low maintenance make it well worth the investment. The value remains consistent in the long run. Thousands of tons of rock detach from the mountain face in a single moment. The first step in making a gypsum board is extracting the mineral from massive mountain ranges where it lies deep underground. Access requires large open pit mines, where powerful drills bore holes dozens of meters deep. These shafts are created to hold explosives, with specially designed charges packed deep into the rock. But this is just the beginning of the operation. Why are the blasts calculated with such extreme precision? The preparation involves strict adherence to safety protocols. This ensures that when detonated, entire layers of gypsum break free from the mountain, making the mineral ready for the next stage of its journey. One can notice how the dust settles after the chief supervisor triggers the blast. Thousands of tons of gypsum crash free from the mountainside. Excavators move in on the piles, scooping up chunks that weigh several tons at a time. It seems like a chaotic process, but in reality, each machine works in rhythm, loading the mineral into the beds of smaller, specialized trucks. These vehicles rumble down dusty paths to a staging area. The loads are transferred once again, this time into giant heavy-duty haulers built to handle massive volumes. From that point, the gypsum begins its journey to the processing plant. The raw stone moves closer to becoming a material essential for construction. Several dozen tons of massive gypsum rocks crash down from the bed of a heavy dump truck, shaking the ground of the receiving area. This violent delivery marks only the first second of a long industrial transformation. Engineers stationed at the site strictly record the weight of every load, managing the distribution of raw material across the massive storage yard, located directly adjacent to the primary processing line. On average, the facility accepts more than 100 heavy trucks every single day, which adds up to thousands of tons of rock entering the relentless production flow. But this is just the beginning of the journey. Excavators move into the storage yard with mechanical precision. The machines scoop up massive loads of gypsum rocks piled high in front of them, their steel buckets gleaming under the dust. They work in a steady, unyielding rhythm, dumping the mineral straight into the gaping feed hopper of the production line. From there, the large chunks are carried on belts into the maw of giant crushers. At first glance, the crushing process appears to be a chaotic destruction of stone, but in reality, It is a highly efficient operation designed to maximize energy use. The gypsum crusher operates with two massive rollers that rotate continuously, applying immense calculated pressure on the rocks fed into the chamber. Large chunks are gripped tightly by the mechanism and split apart into smaller pieces under the even force distributed across the roller surface. This reduction is critical because these rocks contain as much as 70 to 80% pure gypsum, and they must be ground down into particles only a few millimeters across. However, such mechanical violence generates a huge amount of fine dust, which hangs in the air. If workers breathe this particulate matter over long periods, it can lead to serious illnesses, including lung cancer, making dust control systems essential. One can notice how the conveyor belts stretch for hundreds of meters, carrying the ground material deep into the heart of the plant. These belts run non-stop at a steady pace, ensuring that the flow of material remains completely uninterrupted by external factors. Thanks to the fully automated transport system, every single particle of crushed gypsum is delivered straight to the drying and processing area for the next thermal stage. Why does the temperature in the rotary kiln need to rise to such extreme levels? To the untrained eye, heating stone seems redundant, but the material must remain inside the rotating drum for hours to undergo a fundamental chemical change. The heat slowly drives off water, transforming calcium sulfate dihydrate into calcium sulfate hemihydrate, a substance technically known as calcined gypsum. Flames from the industrial burner shoot directly into the kiln, creating an inferno where temperatures range from about 300 degrees to over 660 degrees. Some hotspots within the kiln even reach close to 600 degrees, glowing with intense thermal energy. Engineers carefully monitor and adjust the controls, keeping temperatures steady in different zones to prevent the crystal structure from breaking down too quickly. This strict level of control produces high-quality gypsum powder, which is now ready to move on to the complex mixing stage. Before blending the entire batch, technicians take a small sample to the lab for rigorous testing. There, the powder is mixed with water in a set ratio and combined with specific additives like starch or setting time modifiers to test its reaction. The mixture is stirred thoroughly, then monitored for critical parameters such as expansion, physical strength, and the precise time required for setting. The results are compared against the required quality standards, helping engineers confirm the stability of each production lot. Transition to the next level of formation. Once the formula is finalized, the automated system starts blending the gypsum powder with water and additives in the exact ratio determined by the lab. Each batch of raw material quickly turns into a thick gray slurry ready for the molding step. Drywall is not made of just gypsum powder inside. It is tightly sandwiched between two layers of paperboard, which add structural strength and prevent warping. That is why massive rolls of paper, stretching hundreds of meters long, are fed into the production line as an essential component. Specialized machines carefully unroll and flatten the paper, keeping the surface smooth and completely free of creases. Operators stay alert, adjusting the speed and tension so the paper aligns perfectly with the manufacturing line. This layer acts as the crucial framework, giving the liquid gypsum a solid base to bond with and forming a complete drywall panel. Right after that, the gypsum slurry is powerfully sprayed onto the flattened paper surface through high-speed nozzles. It is visible how the gray mixture spreads evenly, forming a continuous and uniform layer on the moving sheet. This precise application allows the gypsum core to bond tightly with the paper, laying the foundation for a solid board. Next, the layer of gypsum slurry spread over the paper passes through a massive roller system to set its precise thickness. These rollers are designed to turn continuously at a steady speed, pressing lightly on the surface of the mixture. With controlled pressure and accuracy, the entire gypsum layer is leveled evenly from edge to edge. The thickness of a drywall sheet usually ranges from 9 to 15 millimeters, depending on the specific type of product the plant is manufacturing. Everything only gets more complicated as the board takes shape. Right after the gypsum layer is flattened, an automated spray system mists a thin solution over the surface. This coating works to eliminate tiny air bubbles that naturally form during mixing and spreading. If left untreated, those microbubbles could create internal voids and significantly weaken the drywall panel. The solution is usually clean, filtered water, sometimes mixed with additives to improve adhesion. The droplets are ultra-fine and evenly distributed, so they do not deform or disrupt the panel as it is taking its final shape. Thanks to this controlled spraying step, the product keeps a uniform internal structure and a smoother surface finish. After that, the edges of the drywall panel are precisely shaped by specialized machines, creating clean and even outlines. This step gives the product neat edges, making it easier to join and install at construction sites later. Once the drywall panel is fully formed on the conveyor, it moves into the automatic cutting area where precision is paramount. Here, sensors measure the length of each panel down to the millimeter and send signals for the industrial blades to drop in perfect sync. The sharp blades run continuously, cutting the sheets into standard sizes like 2.4 meters or 3 meters, depending on production needs. The cutting speed is carefully calibrated to prevent cracks or surface shifts during the impact. Afterward, each drywall panel is separated and neatly arranged on the conveyor to move on to the next thermal stage. The next step is critical for the product's durability. Each drywall panel is folded so the paper wrapping tightly hugs the gypsum core inside. The mechanical system uses lifting arms and automatic guides to bend the moving sheet with high precision. As the paper folds over, it forms a sturdy cover, holding the gypsum in place and protecting the surface from cracks. Without this paper layer, the gypsum would crumble easily, making transport and installation impossible. At the same time, the paper creates a smooth finish that makes painting or tiling much easier for the end user. Thanks to this folding process, drywall panels gain the strength and clean appearance they need before reaching the market. After that, the drywall panels are moved into a massive drying chamber to remove any excess moisture left in the core. Inside, the temperature is maintained between about 300 degrees Celsius and over 660 degrees Celsius depending on the stage, and each drying cycle lasts around 30 minutes. Hot air is evenly distributed across all levels, making sure every panel dries consistently from the inside out. This step gives the drywall the hardness and strength it needs before moving on to the final finishing stage. Once the drywall panels are dry and stable, they move on to the edge sealing line. Machines apply special paper strips along the sides of each panel, both protecting and reinforcing their strength. One can notice how the paper rolls come pre-printed with logos, product details, and technical standards. This process not only prevents edge chipping during transport, but also gives the manufacturer clear brand recognition. Forklifts carry stacks of finished drywall into the storage area, where they are neatly arranged into tall blocks. Thanks to this system, thousands of drywall panels can be stored efficiently, ready to fill large orders. Organized storage also makes loading faster and safer for the logistics team. When an order comes in, forklifts load each batch of drywall onto specialized trucks. From there, the fleet heads out of the plant, delivering the panels to construction sites and distributors across the market. In the United States, more than 90% of homes today use drywall for interior walls and ceilings. The cost is also affordable, just a few dollars for a standard sheet, making it a popular choice. Its convenience and economy have made drywall an almost indispensable material in modern construction. Thus, the panels leave the factory to become the silent foundation of modern living spaces. 30 to 50 years is the standard operational lifespan of a drywall sheet within the structure of a European building. When a facility undergoes demolition, these panels are not simply discarded into landfills as common waste. Instead, teams collect the debris to dismantle and sort it, granting the material a completely new life in the cycle of sustainable construction. Tens of thousands of tons of these sheets return to specialized recycling plants every single month. One can notice how the sorting machinery separates the useful material from the rest of the rubble. But this is just the beginning of the recovery process. Why do industrial enterprises prioritize recycling over extracting fresh raw materials? It would seem easier to simply mine new gypsum from the ground. However, the economic benefits of processing are undeniable. Recycled drywall costs 2 to 3 times less than the gypsum mined from geological quarries. Furthermore, the material can undergo this regeneration process up to 10 times, while retaining nearly the same physical quality as the original. Heavy manipulators lift the recovered panels and load them into the maw of industrial crushers. The mechanism grinds the solid boards down until they transform into a fine, consistent powder. It is visible how the dust settles as the material moves to additional processing, preparing to serve as the raw ingredient for new panels. Unlike practices in the United States, Europe has developed advanced technology to incorporate recycled paper into the drywall mixture. It gets more complex further on. This approach not only strengthens the structural bond of the final product, but also drastically reduces the volume of raw material that must be mined from the earth. The recycled paper, sourced mostly from industrial and household waste, undergoes rigorous sorting to eliminate even the smallest impurities. When combined with gypsum, it forms a composite that is both durable and environmentally responsible. Everything only gets more complicated as the ingredients enter the modern mixing system. The system feeds recycled gypsum and processed paper into a chamber where they combine with water and specialized additives to improve bonding strength. The result is a thick, uniform slurry ready for the pressing stage. At first glance, the spread-out layer seems soft and loosely formed, but in reality, it is about to undergo intense shaping. Rollers and flattening systems gradually press down on the mass, squeezing out excess air and smoothing the surface texture. Automatic blades adjust the thickness with high precision, ensuring the entire sheet remains strictly uniform from one end to the other. One can notice how the layer travels along the conveyors, being pressed and leveled several more times until it turns into a continuous, hardened sheet. The long strips feed into an automatic cutting machine, where heavy blades drop with precise timing to sever them into panels of standard size. This process runs continuously, ensuring every sheet matches the exact length requirements without deviation. And this is not the limit of the production line. After finishing, the panels are neatly stacked into massive bundles by automated systems. Packing machines wrap the edges with protective material to keep the surfaces secure during future transport. Thus, the product arrives at the customer site, flat, intact, and ready for installation. 2 continents, the Americas and Europe, define the global geography of this production. Drywall is present in most homes, where one can notice the smooth white surface in almost every room. But this is just the beginning. Why is the material considered sustainable? Construction usually implies waste. However, it can be recycled many times, easing the burden on the environment. At first glance, the panel seems simple, but in reality, it holds a long story of technology and sustainability. Thus, the production cycle closes, ready for the next phase.